So I'm Anson, and my student number is 100585118.
I'm Talib, and my student number is 100592417.
And this is our assignment 2 code here, and we are basically going to show how we done our frame buffer objects and our lighting. So we start off with the G buffer, and we bind the G buffer to be drawn with everything in our scene, and then we bind whatever textures come out from the G buffer to the light path shader, and then we calculate all the lighting using the lighting arrays and our LUT textures that we loaded in earlier in our code.
And so in our G buffer, we're going to be taking in all our vertex data, our normals, text coordinates, color, position, eye position, and the vertexes, and then we're going to be passing them in from all the locations that we binded them in earlier, the G buffer information.
These are the color attachments that we set.
Yeah, the colors, attachments, normals, and their positions. And then over here in the vec3 normal function, we have, because usually our normals are are from -1 to 1. With this function, what this does basically makes them from 0 to 1.
This is because our colors are from 0 to 1.
Yeah. And then we are in our main, we're basically just assigning the albedos, the normals, and the positions to the G buffer variables that we had binded.
And once those textures are loaded in from the G buffer to the light pass, we unpack them into our own variables using the texture function. And we use this function right here, or this, what's it called?
Formula.
This formula to display our depth, because our depth is way outside of the 0 to 1 scope, since it's a position and space. Then we have our lighting variable, which is set to 0.0f, meaning that there's no light initially before we calculate any of the lighting. And we also have a distance vertex, which calculates how far in how far from the center of our world each vertex is. And we also have the distance light, which is basically how far the light is from the center of the world. And using those two variables, we can calculate how far each of them are from each other relative to the center of the world. And if they are within our light range, then we use distance intensity to use it as a coefficient in our final lighting.
This basically, just depending on the number of lights and whether they're in range, adds to the lighting or takes away from the lighting. And
we use a for function to go through each of the lights and calculate the Phong lighting that each light adds to it, and then we add it to lighting, which we declared up here as an additive lighting. And once all the lights are finished, it is displayed in our frag color as lighting if we choose to use our buffer type 6 compared to our other types, which display our albedo, our normal, and our depth. If when we have lighting buffer active, if we choose to have a LUT loaded in, then it samples our lighting and compares it to our LUT table, and then it outputs it to the frag color instead.
Alright, now we're gonna talk about what's happening in our demos. As you can see here, our scene is basically a chest, a bunch of mushrooms, and a dagger. The mushrooms are kind of moving up and down. So what we have first is the light's not moving. And if we toggle that, basically our main light moves around. We're gonna activate a singular light, and right now the light's not moving, so you can see we have one light. But if we activate the movement, you can see that depending on where the light is, how close it gets to the center of the object, how far it gets, the light gets brighter.
So the singular light actually deactivates all the other lights that we add to the scene.
And then once we toggle on light volumes, we can see just how big our light is. And once that giant sphere, wireframe sphere, gets closer, it gets brighter. As it moves away, it gets darker. And then we're going to add some more lights to the scene. As you can see, as we add a second light and third light, you can see the specular light on the mushrooms. We can see more specular light on the floor. As he has more lights, the scene gets brighter and brighter. And that's when we have that for function calculating all the lighting. It's adding it to each other just to make the scene brighter. You can see we have 25 lights going on at the same time. The scene gets pretty bright. And then we have a depth buffer, basically showing just how far away each pixel is from the camera. As we get closer, it gets darker, showing that we're getting pretty close. As we get further, it gets a little lighter. And then we have our normal buffer, basically showing us our normals for the scene. And then we have our albedo buffer, basically showing us all the colors for each of the objects in the scene. And then in our light buffer, we have our basic regular light, and we cycle through our LUTs. We have warm, cool, and then our custom LUT type.
And that is our demonstration and description of our algorithms and shader code. Thank you for listening.